A block on an incline has an initial speed of 5 feet per second. How far will the block be from its initial position after 0.5 seconds? The incline is at 30 degrees from the horizontal, and the coefficient of static or kinetic friction is root 3 over 12. We can take little g to be 32 feet per second. Okay, so here I drew our mass m on an incline, and we're given that theta is 30 degrees, and the total time elapsed, t, is half of a second. Okay. And we can go ahead and generalize the block M as a point mass. And I went ahead and defined it to begin at the start of this inclined plane, or the smallest value of what I'm defining to be our x direction, and normal to the plane being our positive y direction. Okay. So let's go ahead and take a look at what are the forces acting on the mass and see how long it's going to take before it slows down and comes to a complete stop given this initial velocity of 5 feet per second. So here I generalized our block M as a point mass M, and along any arbitrary coordinate on this inclined plane, and there's always going to be mg acting downwards with components in the x and y directions, respectively being mg sine theta and mg cosine of theta. So we defined our mass m to start at x equals 0. So we'll say that our initial position is 0 feet. And we're trying to solve for at what point will the mass slow down and reach a final position x, final. And, well, we can go ahead and solve for the acceleration, which is going to be in the negative x direction, by Newton's second law, because we can see that mass times acceleration, the sum of all forces, is going to be, well, if the mass is moving in the positive x direction, we have friction opposing that motion and going in the negative x direction, and that's going to give us a minus mu normal force. But the normal force is nothing but the component along the y, which is going to be mg cosine theta. And we also have our force of the weight of the block, the component of gravity pulling it towards the ground, at a magnitude mg sine theta. And since it's going in the negative x direction, that gives us a minus mg sine of theta. And we could go ahead and solve for this acceleration, plugging in values for theta. We have cosine of 30 degrees and sine of 30 degrees. We end up getting our acceleration being 5/8 of little g in the negative x direction. And, well, now we can go ahead and say that our final velocity, once it decelerates, is going to be 0 feet per second. And from this, we could use our first kinematic equation, solve for our final time that it takes to reach this final position. So that's going to give us v final equals v initial plus acceleration times time. And solving for time, our final velocity is 0. We end up getting that time is equal to minus our initial velocity over our acceleration, which gives us a total time elapsed of 1/4 of a second. So now we know the time in which it takes for the velocity of the block to reach 0. Now we can go ahead and solve for where it's going to be, the final position at t equals 0.25 seconds. 5/8 of a foot. So let's go ahead and write that out. Okay, so I'll go ahead and call this T1 as we want to know what is the position relative to our origin at t equals 0.5 seconds. So at some moment in time, we saw that that time was 1/4 of a second. The block reached a position of 5/8 of a foot relative to our origin. And now the acceleration due to gravity is going to go ahead and slide the block back down. Now we want to see where it's going to be in the remaining time that was left over after 1/4 of a second. That is half a second minus 1/4 of a second is just 3/4 of a second. So now we just have to set up our new our second half of the problem. In this second half, our initial position now is going to be positive 5/8 of a foot. Our x final we're solving for. The total time elapse now is going to be t2, and it is going to be 0.75 seconds, or 3/4 of a second. And our initial velocity is 0. Our acceleration now is going to be different, as the force of friction is now opposite to what it was initially. So now in this case, the motion of the block is going to be going in the negative x direction, and so the force of friction is going to be opposing that motion, going in the positive direction, which is mu mg cosine of theta. So really, all that's changed is a sign. And as we saw before, the Newton's second law gives us an acceleration. This time, ma is equal to positive mu mg cosine theta, and the force of the component of gravity in the x direction is still a minus mg sine theta. And so this gives us now a new acceleration. Plugging in the values, we end up getting of minus 3/8 of little g. From this, we can go ahead and solve for the final position. This does not look good. we're getting a value less than the origin, which is not terrible, but I suspect that it's wrong. And it is wrong because uh, the amount of time it took for the block to accelerate, to decelerate to a velocity of 0 was a quarter of a second. We want to know where the block was after half a second. So 1/2 minus a quarter is just 1/4, not 3/4. So our T2 should be 1/4. And so when we go ahead and plug that in, you get rid of this factor of 9 that I did. And we end up getting 27 divided by 9 is 3. That looks much more reasonable at 2/8 of a foot. So we end up getting our final answer of 2/8 of a foot after t equals t1 plus t2 equals 0.5 seconds. Now, it wouldn't be crazy if we got a negative value, because that would just indicate that enough time has elapsed for it to go back to the origin, and well, there is no negative incline for it to go on, so we would know it would just stop at the origin. But I had an inkling that's not what the problem wanted, and so in fact we were wrong. I was wrong. A quarter, 1/2 of a second minus 1/4 of a second is just a quarter, not 3/4. Our final position after half a second is 1/4 of a foot. Now we're done.